All right. Hello, friends. Good morning, good evening, whenever you're watching this. Today's lesson, again, builds on everything we've done so far. The previous lesson, we talked about how to solve equations with variables on both sides, and you need that same knowledge for this lesson today. Today's also requires you to combine like terms, distribute, and to get variables to one side and then solve your equation. So everything we've done so far is going to be useful for today. And if you can do all of that and you feel comfortable with that, this lesson will probably be a breeze for you. We're going to talk today about numbers of solutions. So remember, a solution is something that makes it true. And you can have three different options here. You can have one solution, you could have no solution, or you could have an infinite number of solutions. So the first one we're going to talk about is when we have one solution. And you can see I have this scale here with some boxes. So in this case, each box here has to be 10 in order for this to balance. Think about it as each box has to represent the same number. So 10 would be the only number that each of these boxes could be, or this could equal 30. Now, how can you tell? If your last step has a variable equals any number, n equals 7, x equals 5, y equals 100, anything like that tells you you have one solution. And for your answer, it's going to be exactly what it's been ever since we've started solving equations, where you would just write x equals 10. And that's what you guys are used to. We've only dealt with equations that had one solution. So once you have x equals a number, circle it, that's your answer. The next one we're going to talk about is when we have no solutions. Again, same idea here, how above each box had to be the same number. Down here, is there any number that you could put both in this box and this box to make them equal? And hopefully you're like, no, there is no number here that we could put where both boxes would be the same, where our scale would even out. If we did 10 and 10, this would be 30 total on this side, only 23 on this side. And that's always going to happen, no matter what, with these two boxes being the same number. No number you can add will make these equal. So when you have no solution, you'll see something like 7 equals 5, or 8 equals 9, or negative 15 equals, I don't know, 10. Whenever you have two different numbers on both sides of your equal sign, no variable left, just a number equals a different number, that means no solution, because negative 15 does not equal 10. It doesn't work. And then we have our last one, which is infinite solutions. And if you look in here, again, same box, or each box has to be the same number. You could put in 8 and 8, 10 and 10, 100 and 100. No matter what, these sides are going to weigh the same and your scale is going to equal out. So it doesn't matter what number you put, there are an infinite number of choices. And that's what the infinite solutions are. If your last step has some number equals that same number, then you have infinite solutions. Or if you have exact same thing on both sides of your equal sign. So if you see 5 equals 5, or 8 equals 8, or 8x equals 8x, the same exact thing on both sides, that means you have an infinite number of solutions, and what you are to write there is all real numbers. Okay, if you need to get this down, pause me, take a minute to get it down. Otherwise, I'm going to move on to these two example problems before you try these three. Okay, so again, we're combining everything we've learned so far. So we need to first simplify, get our variables to one side, and then we can solve. So I'm going to draw my line down my equal side. I'm going to simplify first. I don't see anything to distribute, but I do see two terms with y's over here, so I'm going to combine them. I have a 4y and a minus y to give me 3y plus 7 equals 10 plus 3y. Okay, now I'm going to get my variables to one side. So I'm going to subtract 3y, subtract 3y, cancel. Oh, but I have a 3 and a minus 3y over here too, so those are also going to cancel. And I'm left with 7 equals 10. And if you look from up above, when I have a number equals a different number, that means no solution. So this here, my final answer would be no solution. All right, let's do this next one. Draw my line on my equal sign. Start by simplifying. Again, I don't see any number outside of any parentheses, so I can't distribute, but let me check to see if I can combine like terms. I have a 2c and a plus c, so that's going to give me 3c's plus 7. Okay, and then I have a 3c, and then I have a negative 14 and a positive 21, so I can combine both of those things. 21 minus 14, 10, 9, 8, 7, and 1 minus 1 is 0, so I got plus 7. Okay. Subtract 3c from both sides. Some of you might already know the answer already, because we have to get our variables to one side. So 3c cancels. Oh, this 3c also cancels. And I get 7 equals 7. When we have some number equals that same number, 7 equals 7, we have infinite solutions. So we're going to write all real numbers. So what that means is that no matter what number you plug in for c, you're going to get a number equals a number. No matter what number you plug in, you're going to end up with a true statement. Okay? So again, if you get two different numbers on both sides, no solution. Same number on both sides, all real numbers. And then the last one was what we've been doing. X equals something. That just means there's one number that you can plug in that gives you a solution. So one number. Okay, there are 3 problems here. I want you to pause me and give these a whirl. The first one you need to distribute. This one just get your 4 to the other side and then solve. This one distribute and then get your variables to one side and solve. I'm looking for you to say one of these things. All real numbers, no solutions, or x equals a number. Okay, 3 problems. Your time starts now. Come back to me when you finished, or come back to me if you're stuck. Right. Either you're stuck or you're finished. I'm going to work through this first one, and then you'll just see the answers in the work for the last 2, but I'm not going to talk us through it. Okay, so first things first, I need to distribute my 2, because simplifying is always first. Start with distributing and then combining, and I get 2x plus 4 equals 2 times x is 2x. 2 times 2 is 4. Again, some of you might already have the correct answer from here, but now I need to get my variables to one side. So I'm going to subtract 2x, subtract 2x. These cancel. Oh, these end up canceling too, and I get 4 equals 4. So infinite, which means all real numbers. Oh my goodness gracious. Okay, great. All right, the next 2, subtract 4 from both sides. You get 2x equals 0, divide by 2, x equals 0. One solution, so we just write it as x equals that number. The last one, distribute that 4. You get 8x minus 4 equals 8x plus 7. Take away 8x from both sides, and you get negative 4 equals 7. Therefore, no solution because those 2 numbers do not equal each other. All right, check it out. If you made a mistake, go back, fix your error, find out what you did wrong, and please correct it. And once you are finished with that, there are a few independent practice problems here. I want you to get through all 6 of these. If you're feeling spicy and like it wasn't challenging enough, please come down here. But if you're not feeling up for that, that's okay. I do need you to complete 1 through 6, however. Okay? Complete those. Do your mastery check. If you're completing this asynchronously, please send me a message once you finish your work. All right, have a great day, and I'll see you soon.